Hello, this video or lecture will be going over the step turn lathe. That's your second project you'll be doing in your App 7. Just pretty much does a G71, G70 can cycle to cut this profile. What we are doing here is we are actually going to be calculating how to get the correct chamfer size without using cutter comp. Okay, now that first project, I really didn't care if you tried to use cutter comp and it worked. If it didn't, as long as you had that chamfer on that front edge, we kind of let it slide. So cutter comp works a little bit different than it does on a mill. On a mill, you pretty much need cutter comp to cut any profile with an end mill. Okay, it always has to look at that tangent point of that end mill. On a lathe, if I could draw a pretty crude cutting tool, so here you have your tool nose radius. Can't even spell tool nose. Tool nose radius, okay? So when we calibrate this tool, we hit this tangent point with whatever we're calibrating with in the Z, and the same thing within the X. So when it's cutting in straight X or straight Z, it doesn't need cutter comp at all. The only time you need cutter comp is to calculate where this tangent point is when you're doing radiuses on your part or angles. It's very common for machines not to have cutter comp. Industry kind of looked at this as saying that, okay, you don't really need cutter comp to run your part. This is an opportunity to get some more money out of the businesses. So they say this is an option if you want cutter comp. It is pretty common not to have cutter comp on a lathe. So you have to calculate where that tangent point is and so forth. Well, in our manual, it kind of explains it a little bit for you. So on page 62 of your manual, if you kind of look, this is your tool. And you notice that this tangent point to cut this, to start that is way down here. The X is way down here. The Z is still at the start. And then when it finishes, the X is at the finish, but the Z needs to cut past. Because once again, that's that tangent point down there. Okay, so for different angles and for different tool nose radiuses, you have to offset different amounts. Our print calls out for a 45-degree chamfer, and our roughing tool is a 31 thousandths radius. Now I do know that our finish tool is 15, but if you calculate it out for that 31 thousandths, it'll cut your chamfer just fine. That 15 thousandths actually will not cut the chamfer because the 31 thousandths already went ahead and did that. So you got that 45 degree angle, 31 thousandths. So all of our X dimensions need to be offset 36.6 or 0.0366, and all of our Z's are 0.0183. Now notice that's twice. Once again, this is a 45-degree chamfer. So remember, all your X's are doubled, and that's the reason why it's twice as much in the Z. So if we go back to our print now, we'll kind of figure out this first one here. So our start point for this is 1.125. We need a 30-second chamfer, 031. That's our chamfer, but now we also have to compensate for our cutter comp. So in this case, in our X, I'll pull out my calculator quick. So we got 1.125 minus 31 twice, minus is 1.0264. So that's this point that we need to go to. So inside you have your G71, G71 P1 Q2. So your P1 would be X 1.0264. Okay. Then your next move would be Z0. And now we have to calculate where our endpoint is. So this is for the X. Our Z, we'll go up here. Our print tells us it has to be a 30-second in, which is just 031. And then from the manual, we need to offset that 18.8, so 0.0188. So we're going to subtract those. So you got 8, 9, 4, So 0.0498 would be your Z. And then from there, you just kind of go over, and then you have to do that same thing for each of those chamfers. So this will get you a nice clean chamfer, right to size. Like I said, it's very common. When you get into radiuses, there's a lot more math into it. But it still can be done. So if you have any questions on it, please come and see me. Otherwise, good luck.